Welcome and thank you for joining us for today's webinar, Next Generation Network Packet Brokers, Defining the Future of Network Visibility Fabrics. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speaker is Shamus McGillicuddy, Research Director at Enterprise Management Associates. Shamus has more than 12 years of experience in the IT industry, primarily as a journalist covering the network infrastructure market. At EMA, he is the Senior Research Director for the Network Management Practice. And before I hand things over to Shamus, I wanted today's audience to know that we will be concluding the event by taking your questions. Please feel free to log them anytime using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA that will include the on-demand playback as well as some additional resources, so I hope you'll check that out. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thank you, Raleigh, and thanks everyone for joining us today. As Raleigh mentioned, this is Next Generation Network Packet Brokers, Defining the Future of Network Visibility Fabrics. It is a multi-sponsor research project that we just published this week. As we do with most of my research projects, we have multiple sponsors from the relevant industry. Garland Technology, Gigamon, NetScout, and Niagara Networks are all vendors who provide solutions in network visibility space like TAPs and network packet brokers and software in that area and so forth. So thanks to these 4 vendors for making this research possible. As for the agenda, this will probably be about a 30-minute presentation. I'm going to start out by talking about some definitions, some research goals and methodology to sort of set the stage for what we're looking at here and how we got some insight into what's happening in the market. Then we will look at the state of network visibility fabric deployments, looking at how enterprises are gaining access to traffic for security and operational tools. Then we will look at defining the network visibility fabric of the future, which just looks at what kind of features are important to enterprises moving forward and how they're gaining visibility into the public cloud and some stuff like that. Then we'll look at how people actually go about using their fabrics. Specifically, we'll look at a little bit at how network operations and security operations collaborate with these fabrics, which is important. And we'll close out with some general benefits and challenges that we're seeing in this realm. So first, definitions, research goals, etc. What is a network visibility fabric in this context? It's kind of a shadow network. It collects and delivers traffic, primarily packets, but also it might generate NetFlow or SFlow or IPFix. It might also be adding like metadata into the traffic for the purpose of delivering it to IT operations and security analysis tools that basically process traffic to gain insight into what's happening. Or in the case of inline use cases, like might also be introducing like security controls in the network. You might plug a firewall into an inline network packet broker, for instance, or multiple firewalls. It typically includes TAPs, span ports, software probes. TAPs are devices that plug into a network interface and mirror traffic from a network device without necessarily impacting the performance of that device. Span ports are featured on lots of routers and switches. You configure a port on that switch to mirror traffic from that device to tools or to a visibility fabric, depending on how elaborate your operation is. Span ports typically are less reliable than TAPs and can impact the performance of that device. And then you got bypass switches, which are specific to inline use cases, and then network packet brokers, which are kind of the granddaddy of what we're talking about here. These are appliances that are known by many names, but network packet broker seems to have caught on over the last few years as the default descriptor, but we've called them other things such as network visibility controllers and network monitoring switches and matrix switches. These are typically the core of the fabric and even the aggregation layer of a fabric in visibility terms. It's something that aggregates traffic from multiple spans, TAPs, other packet brokers, and then processes that traffic by adding metadata, filtering and modifying it, time-stamping it, maybe decrypting it, and then sending that groomed and or load balanced traffic to individual tools for analysis. Probably most of the people on this call know all of this already, so sorry about that. Research goals. I wanted to identify the current and future state of visibility fabrics with a particular focus on the packet brokers themselves and how things are changing there. So we looked at implementation strategies and product requirements, current use cases, emergent solutions for future use cases and new use cases, and then technical and business challenges. In terms of methodology, we surveyed 250 enterprise IT professionals. All these people hold mid to executive level positions in enterprise and IT security organizations. They possess subject matter expertise, which means anyone that was identifying themselves as someone like a network administrator was usually tossed out. We wanted people like engineer positions or architects at minimum, developers and things like that. They had to have network packet brokers currently deployed in their infrastructure, and they had to be directly involved in at least one aspect of the visibility fabric and network packet broker lifecycle. So we asked them, how are you involved? Are you evaluating and researching products? Are you purchasing products, implementing them? Are you maintaining them and updating them? Or using tools that are connected to them? We found that people in the security group tended to be more likely to be users of the tools that are connected, and in some cases were more likely to be maintaining the actual fabric, but were less likely to be product evaluators or purchasers or implementers, whereas people in IT, like network engineering and application management and the IT executive suite, people on that side of things were equally likely to be involved in all these stages of the life cycle. Here are the demographics of the people we surveyed. You see IT role, mostly IT staff and middle management, but more than a third were in the executive level. In terms of grouping, I broke it into two. 25% were security, that's security operations, asset security, security engineering, chief information security officers, and the other 75% were like general IT positions like IT operations, network operations, data center operations, application management, project management, things like that. Kind of a 50-50 split here, almost exactly between what I defined as mid-market in this context to be 250 global employees to under 2,500, and then large enterprises 2,500 or above. In terms of revenue, mostly companies with 100 million or more in revenue, but 37% said they had less than 100 million or no revenue at all because they were a government agency or a non-profit. That latter group was only like 2-3%. And then geography, and almost even split between North Americans and Europeans. The Europeans were mostly Germans, UK, and France, three of the biggest economies in Europe. And then 19 industries were found in our random sampling. We didn't look for specific industries, but the ones that sort of rose to the top here were the financial sector, software companies, retail, distribution, wholesale, app or cloud service providers, and then manufacturers of non-IT products. Manufacturers of IT hardware and network hardware were also detected, I think 5 or 6% of the sample, but we break them out separately in the crosstab analysis. So in terms of visibility fabrics, we recommend that enterprises rely primarily on taps in the visibility fabrics due to the aforementioned benefits there. They're more reliable, less likely to impact the performance of a network device than the span ports themselves. So we think 100% taps would be ideal, although it is expensive. Here you see very rare for an enterprise to have 100% taps, but the majority of the market, it's the 2018 group, the blue bar. We also surveyed this topic in 2013. You see things haven't changed that much, a slight shift towards more taps, but what we're seeing here is generally enterprises have 50 to 75% of their mirrored traffic coming from taps versus span ports, and that's good to see. We'd like to see those numbers shift to the left. You see very few have a majority approach to spans. I mean, very few even have more than 75% of their mirrored ports coming from span versus tap. So keep up the good work. Keep moving towards 100%. You'll probably never get there unless you have unlimited budget, but that's the ideal approach. Where are packet brokers deployed? You see the most popular approach here in terms of the blue bars. That's current versus in green 12 months from now where they might be added. Data center core and data center edge, the ingress-egress points are the big areas of deployment here. Also pretty popular to see them in top of rack and remote sites. Slightly more than a third having remote sites. I doubt they have them in every remote site, but they probably have them in some, maybe some of the strategic sites that have more performance and security requirements and more users, or maybe more secured, more sensitive data that's in transit from those sites. And you also see there's actually a lot of planned activity there compared to other areas. They're planning to deploy them in remote sites, 30% of them. So that's an interesting indicator there. And then campus backbone, least likely place for a network packet broker to be deployed, although we also see some decent activity there in the future. So in terms of how extensive these visibility fabrics are, you see the goal would be to have 100% coverage of all network segments, but that's also going to be difficult for a variety of reasons, which we'll look at in the next slide. What you see here is it's very rare for an enterprise to have 100% coverage of their network with their visibility fabric. So we broke this into two pieces, the NetOps coverage and the security coverage. And you see in terms of coverage with network operations tools, only 5% have 100% coverage of their network. Twice as many have 100% coverage of security, which is obviously a bigger priority. But for the most part, you see the sweet spot seems to be like 60 to 80% for security and 60 to 90% for network operations tools. So the ideal is 100%, but very few people get there. And why is that? Well, 30% of them say they don't need 100%. Maybe there are parts of their network that they don't need to manage performance that closely. And maybe there's parts of their network where they aren't worried about security. Maybe guest networks don't require close security coverage as long as people are sort of walled off from the enterprise network, or maybe there's just their security requirements are lower. But the other 70% do have challenges, and these are the top four. Network complexity is the big one, so maybe they don't have a good understanding of their network. Maybe they have like different groups controlling different parts of the network because it's so complex, and they just can't instrument certain parts of it. Compliance risk is another big one. There are certain parts of the network where they don't want traffic to be captured and mirrored to a central a network packet broker for decryption, for instance. Decrypt the traffic so we can see the payload and understand how the application is performing. And they don't want to do that. They have privacy or compliance risks associated with that. Lack of budget is number 3. So network packet brokers have a reputation for being expensive appliances, and obviously that's a factor here. And maybe you don't have enough taps that you can't buy enough taps with your budget allocation. And then shortage of taps and span and network packet brokers. Here's an issue where, this can be partially related to the budgeting piece, but it also could be, you just don't have the time to instrument the entire network with the staff that you have, and you don't have the resources or the expertise to get it done. So defining the visibility fabric of the future. Here are the critical architectural features of network packet brokers moving forward. High availability and fault tolerance, number 1. So they want an appliance that's going to keep going that is has zero mean time between failures, or infinite mean time between failures, I guess is the right way of phrasing that. Event-triggered automated actions. So for instance, maybe the packet broker is smart enough to detect an incident that will trigger it to send a certain flow of traffic to a network recorder or a intrusion detection system or something. Having enough smarts in the box to do that and make things easier for the operational team. Onboard data storage, that's a consolidation play. They want to, instead of having a separate device that captures the packets, maybe they just want to store it on the actual packet broker. Or maybe, in the case of those, we saw some activity around remote sites. Maybe they might have like a requirement for the network packet brokers in their remote sites to capture the traffic locally rather than backhauling it over the WAN, which would create an extra expense. And then direct and embedded security controls, number 4. So actually having like some sort of firewall capability on a network packet broker seems to be interesting to them. And that's more interesting to the people who were in the security group, obviously. That's no surprise. People in the security group are also more interested in NEBS compliance, which you see at the bottom of this list. Of less interest, clustering and support for copper and fiber on the same appliance. So critical packet manipulation features. We asked this question 3 ways. What are the most important features for your network operations monitoring tools? What are the most critical packet broker features for your out-of-band security monitoring tools? And what are the most critical features for your inline security solutions? So here's the network operations list, and at the top of the list is decryption. They want to see those payloads. They want to understand the applications represented in the traffic, see who's in, what the activity is, and who's the source of that activity, and also time stamping, very important, especially probably important to companies that rely on really precise measures of performance. And then load balancing at layer 2 through 4 in two ways here, non-encapsulated traffic and then encapsulated traffic, like VXLAN, being able to load balance by VXLAN at layer 2 through 4. And then outbound filtering was also important to them. For out-of-band security, you see intelligent deduplication and metadata generation at the top. So also NetFlow or IPFix generation, also important to them. Middle of the way there, IPv6 support, packet slicing, and basic packet deduplication. This list is actually, the list is longer in terms of all the things I think there were like 20 or 22 features we polled them on for each of these, and these are just the ones that rose to the top. And then for inline, you see a lot of focus on filtering here, both inbound and outbound layer 7, inbound and outbound layer 2 through 4, IPv6 and decryption at the top, also basic packet deduplication and advanced header stripping, like stripping out MPLS and GRE headers. We're interested in getting a sense of what people are doing with Whitebox network packet brokers, something we've seen, we've seen switching be affected by the so-called Whitebox trend. People that want to emulate the hyperscale data center operators are disaggregating network hardware and network software, usually buying network software from a strategic vendor and then getting the network hardware from a original design manufacturer, or if customer support and sales engineering support is really important to them, they might get the hardware from a mainstream network hardware vendor that's disaggregated their hardware, like Dell's been doing for a few years now, and other vendors have just started doing, like Cisco. The same disaggregation trend you see there, you're seeing in the network packet broker space, where people can run network packet broker software on an off-the-shelf piece of switch hardware. A lot of vendors doing that today, either doing it completely committed to it with all their products, or doing it to some extent, but also still offering appliances for some of their use cases and certain customers. There's certain challenges with disaggregation. These are the top three. Internal skills gap. Network engineers are not system integrators. They've been buying vertically integrated network hardware for years. They're not used to buying hardware from one vendor, software from another vendor, installing, testing, and validating those devices or those solutions. Not something that they're well versed in. Commodity hardware lacks the resources for advanced functionality. So these are switches that are running commercial off-the-shelf network silicon. They do not have custom ASICs. They're optimized necessarily for advanced packet processing and filtering and things like that. So they don't have that available to them. In certain instances, that might mean that they have to have a vertically integrated network packet broker appliance further up the chain that they would forward traffic to for advanced packet processing, or they might have like a pod of servers that are just running the advanced packet processing features that you forward traffic to, or maybe they have some custom NICs plugged into the box to take care of it there. And then number three, divided support model. In most cases, probably the software vendor is going to be the first line of support, and they may not have a good integration with the hardware provider, depending on what you procured and who you procured it from. Do they have the ability to solve a problem across hardware and software? That's going to be something you probably want to talk to your vendors about. I mean, vendors that are making a strategic decision to go with a disaggregated solution probably are more mature here versus those that dabble in it, maybe not so much. And then why disaggregate? Top reasons: flexible software options, flexible hardware options, reduce complexity, even though it may introduce a skills gap, seems to be appealing as well. And then reducing operational costs and CapEx are less of a priority, but still something that's on the top of mind for slightly less than a third to about a quarter of these guys. Traffic capture in the public cloud. How many are collecting traffic data in the public cloud for analysis today? 37%. And 33% are planning to implement a solution in the future. The rest had no specific plans. No consensus on the best approach here. About a third are using or prefer to use native traffic capture solutions like Azure Network Watcher. Another third are using software like network packet broker software or TAP software implemented via cloud providers marketplace, which seems to be the simplest approach here. And then another third or so are using software that they install directly into cloud workloads. So this seems to be something that's still shaking out in terms of the de facto approach. What are they actually capturing? 55% collecting packet header information, 57% collecting packet metadata like KPIs that network packet broker software in the cloud might be able to create and generate. And then 56% in the middle there collecting full packets, which I think is like a very something that would be rarely done, probably something that would be kicked off by the other two approaches. But you see the majorities are doing all three of these. But this is an area that's probably still maturing, still like a couple years away from really settling down. A lot of vendors in the visibility fabric market have only introduced solutions in the last 2-3 years at most, and so it's something that's still developing. Using the network visibility fabric, here we look at how the network and security teams share that fabric. What's their approach to instrumenting the network or the fabric? How do they have change controls in place? Things like that between these two groups, because there can be contention there depending on how extensive the fabric is. I mean, about a little more than half here, have formal processes and best practices in place that govern how these two groups instrument the network. So the security group maybe have like some sort of ticketing process where they request that the network engineering team help them connect the security tool. If it's inline, then maybe the network engineering team helps them validate that it's putting that inline tool into the fabric, plugging it into an inline network packet broker will not impact performance. This is a best practice. I think EMA would recommend this. Establish those processes and best practices to avoid conflicts over packet access, to avoid impacts on performance, to make sure that you have all your network segments covered. At least the ones that are important to you. Still 39% have an ad hoc approach, which is not good. 4% have a nice approach here. They've got a third-party internal intermediary, maybe an engineering group that specializes in just managing instrumentation because it's a huge fabric. And then 6% said there's no collaboration at all, which is playing with fire. We found that those that have formal processes and best practices here are more likely to have broader coverage with security tools. They're more likely to be closer to 100% of segments covered by security, and they're also more likely to be using Layer 7 packet manipulation features, which means they are probably more aware of what the fabric can do through that collaboration with network engineering and operations. Inline security packet broker usage. 78% said they have connected security tools to an inline network packet broker. That's higher than I was expecting. And 86% of organizations with those formal network and security collaboration best practices and processes. So it drives up inline use case as well, or at least inline use case maybe drives formal collaboration. That's probably the better way of looking at that. We asked them how you apply patches and updates to inline tools when you have them connected to packet brokers. 43% are leveraging high availability architecture, 34% scheduled downtime, 22% allow the traffic to pass through uninspected. Here are the tools that are connected to packet brokers and visibility fabrics today. So security seems to be the big opportunity here today. Looking from the left, orange is currently deployed, green is planned for deployment within 12 months. Firewall, big one. Web application firewalls, data loss prevention, security analysis, SIMs, DDoS protection and detection, advanced threat detection, intrusion detection and prevention. All security tools. Then once you get to the middle of the list, it's compliance monitor, application performance monitor, network performance monitor, decryption appliances, data or packet recorders, and then at the bottom of the list, troubleshooting devices, which tend to be more ad hoc connected to visibility fabrics, and VoIP UC video analyzers. In terms of green, the future activity seems to be an indication here that there's more plans for connecting UC video analyzers to fabrics in the future. Also, advanced threat protection, behavioral analysis, and application performance monitors and network performance monitors are seeing a little bit of future activity within a year, so that's going to be expanded. So benefits and challenges of network visibility fabrics. Here are the top responses. At the top of the list, you've got architectural complexity, which we've already seen tends to inhibit 100% coverage of network segments with a visibility fabric. Then you have lack of personnel with visibility fabric skills, scalability or ease of expansion, and then traffic that is overwhelming the visibility fabric. Those are the top four. What they're not struggling with is budget, despite the fact that packet brokers have a reputation for being premium products. And they're not struggling that much with poor product quality or reliability. So the product quality is high. Affordability isn't an issue for most of these guys. It's really things that they need to work on internally for the most part, in terms of like managing capacity, managing their personnel, upskilling the personnel, dealing with complexity. Benefits. These are the top 6 benefits of using a visibility fabric and network packet brokers. The top 2, enhanced IT productivity. So you're streamlining workflows when you have better access to traffic with your tools. And then improved IT collaboration. With better access to data, you are facilitating collaboration. For instance, If the network team and the security team have access to the same data set, then you have common ground for talking. It's like, hey, I see in this network segment this weird behavior, and in my network performance monitor, I'm seeing unusually high peer-to-peer traffic. What do you see in your security tool? And that security guy says, well, let me go and let me take a look. And they see the peer-to-peer, and they're like, oh, wait, this is bad. We get peer-to-peer traffic from St. Petersburg. That's not a good sign. Because they have the same fabric with the same data sources, they can collaborate. Then secondary benefits, IT agility. Being able, more responsive to the business. You have a good handle on how to deliver traffic to your analysis tools, your security tools, your performance management tools. You have a better handle on capacity. You have a better handle on how the network behaves today and how it might behave in the future if new business initiatives impact it. Accelerated security incident detection. Pretty obvious why that would be the case. You need better access to data, better ability to detect something. Faster resolution of IT service trouble, same thing. And then improved SLA performance, so the network performs better in general. Highly available, highly performing when you have a better handle on your data, your traffic data. So in conclusion, today's visibility fabrics, they rarely cover 100% of a network, and complexity and compliance risk are the bigger barriers there, although some say they don't need 100% of coverage. The sweet spot seems to be more than 60% of coverage. Security use cases, it's more important to have a broader amount of segments covered. Critical packet broker features vary by use case. Layer 7 and Layer 2 through 4 filtering and decryption are critical to inline security. Decryption, timestamping, and load balancing, especially at Layer 2 through 4, are critical to network operations tools. Enterprises have significant interest in disaggregated packet broker solutions, but there's a skills gap there. There's some concern about the divided support model, but it's more about flexibility than cost savings, the interest there. No consensus on public cloud traffic capture approaches, but there is significant interest. Within a few years, looks like 70 to 80% of enterprises will have that going for them. We're going to do some more research there towards the end of this year, to sort of zero in on what's happening with cloud and performance management and network operations in general. Many network operations and security operation teams have formalized fabric collaboration, and it does lead to a better security posture, and we advocate that wholeheartedly. And then finally, visibility fabrics typically boost IT productivity and enhance IT collaboration. So what's not to love about that? With that, I'm going to turn it back over to Raleigh to moderate the question and answer session in case anyone has questions. But thanks for your time and appreciate it, and feel free to check out the report in our research library at emausa.com.
Great. Thank you, Shamus. And I will include a link to the report for those of you who are interested in learning more about it. I'm going to go ahead and jump into the questions, starting with the first one, Shamus. How are these guys managing packet brokers?
Okay. So the plurality of them said that they preferred to have like a central console that enables like GUI-based management. A very small number of them, or not a very small number, but it's a thin minority, I guess would be the word I'd use, preferred like CLI-based management of individual packet brokers, and another small group said they liked having like a GUI for each individual packet broker. But the most of them said we need like a nice central console with GUI-based management, drag and drop features and stuff like that.
Thanks. The next question is, how are people doing advanced packet processing with Whitebox packet brokers?
Okay, I touched on that a little bit. So based on what I've seen from the vendors out there, we didn't actually, we did ask this question. I don't have it in front of me, but so I think there wasn't like a majority approach to this, but one chunk of them said that they forwarded traffic from their disaggregated systems to a vertically integrated appliance from a premium vendor that had the advanced features they needed. So they have like a hybrid visibility fabric with a mix of vertically integrated and disaggregated solutions. And then some of them said that they're plugging NICs into the disaggregated systems that could host some advanced packet processing features. And then another chunk of them said that they had sort of like applications that do the packet processing features on like a cluster of servers that they forwarded traffic to. And then a very, very small number of them said that they didn't need these features at all. So those are the people who said, we're happy with just like layer 4 load balancing and basic deduplication, maybe not even that. Maybe they just needed something to aggregate traffic, and the basic features of a mid-tier packet broker running on a off-the-shelf piece of hardware was all they needed. But that was pretty rare.
Okay, great. To wrap up, I have a two-part question. It is, what's the best practice for packet broker ownership? Who should be running that fabric?
Okay. So we asked. So it seems to be that network operations and network engineering teams are the groups that tend to be running the show. And then they bring in security operations groups at the latter stages to facilitate, the initial, like, let's get all of your tools, the flows they need, and things like that. And those are the three groups that are like most involved. But from the perspective of the CIO and the IT executive suite, they see like a broader set of teams involved. So they said, actually we want the security engineering group involved too, the asset security guys. Also, the application management team needs involvement because they're doing lots of packet-based application performance management perhaps. And they even have like the help desk involved in some cases, not a lot, but in some cases. But the core three are network engineer, network operations, and security operations.
Great. Thank you, Shamus. And I wanted to thank our audience for joining us for today's webinar. I do hope that you'll check out that email that I'll be sending later today. It will include the on-demand playback, a link to this report, and as a thank you for those of you who joined us live, I will also send a PDF of the slides. I hope that we will see you at a future webinar. Thanks again for joining us, and enjoy the rest of your day.